So people who are joining, just type in the chat so that I know कि it's working for you. At times the chat is randomly disabled for some people. Also, people on YouTube, uh, do type in the chat. I am seeing whatever is being done. And yeah, if you want to join the class link is here. Okay? You can also find my profile here. You can follow me to know about all my classes. Also, on YouTube, last time there was a problem ki the sound was only coming from one side of the earphones. So tell me if that is still an issue. Hello Sharan, hello Pavan. What happened? I'm just switching between YouTube and Unacademy. स्टार्ट क्या हुआ है? आई एम जस्ट वेटिंग. लोगों को ज्वाइन तो करने दीजिए. आई एम प्रिटी श्योर कि यू हैव जॉइंड माई लास्ट क्लास ऑन शॉर्टेस्ट पाथ एज वेल. सो प्रिटी मच सेम स्टफ, बट आज मैं फ्लॉयड वॉशल करूँगा इंस्टेड ऑफ बेलमन फोर्ड. So last I took one class on shortest path before also. I did Dijkstra and Bellman Ford tab. Aaj I'll be doing Dijkstra and Floyd-Warshall. जो लोग भी क्लास में है, please type something or the other. Just type something. It doesn't matter. बढ़िया ठीक है. कल का C का कोड समझ नहीं आया. What was C? तो अपने हिसाब से कर लिया ना. बढ़िया. तब तब और क्या प्रॉब्लम है? We didn't discuss. नहीं नहीं, I sent the code for C, right? Or I sent code for the two Ds, I think. I'm not sure. Which one did I send my code for? I sent my, yeah, C का जो solution I sent, that did not pass. वो तो वही है जो जो वो कर रहे थे, वही कर रहा था मैं. Just finding a cycle. Hello Ahad. So YouTube में I'll be checking बीच बीच में. So okay, there is obviously a delay on YouTube, like a 20-second delay. So I'll be checking बीच बीच में. If there's a question, it'll be answered थोड़ा सा late. So hopefully that is not a problem for you guys. Probably, I mean, good problem or not, it's subjective. Okay, so I will start. So आज का agenda is this कि I will first discuss. इसको spell करना is a pain. Hopefully this is right. So Dijkstra, I'll start with Dijkstra, which is a single source shortest path algorithm, or in short it's called SSSP. ठीक है? I'm gonna teach the algorithm itself and then I'll be solving a problem वैसे type का. ठीक है? And the second algorithm I'll be teaching is Floyd-Warshall. ठीक है? Floyd-Warshall is an all pair shortest path algorithm. ठीक है? So what Dijkstra does is, given a graph, ठीक है, there will be one source node. ठीक है, ऐसे करके बहुत ही एक ग्राफ है and there will be one source node. From that source node I will be finding the shortest path to every other source node. The running time of this algorithm is O of n log n. ठीक है, and Floyd-Warshall, for every pair of nodes I will find their minimum. ठीक है, is this clear? So for every pair of node, so like there is not one source, so between any pair of node I can find the minimum distance. And yeah, iska log iska runtime is O of n cube. ठीक है, and this is a dynamic programming algorithm. ठीक है, a bit harder to understand, but iska code is literally 5 line का, like 5 line का even after taking the loops वगैरह. Like the main part of the algorithm is just 1 line. So that is fun. So that I'll be teaching. The problem I'll be solving in the end is based on Dijkstra only. Okay, not Floyd-Warshall. Floyd-Warshall I'll be teaching today, and I'll be taking another session on shortest paths after this one. Usme I'll be doing Bellman-Ford, and I'll be solving 2 or 3 problems on Bellman-Ford and Floyd-Warshall. Okay. The third algorithm that I'll not be teaching today is Bellman-Ford. So this is also a single source shortest path algorithm, but इसमें you can detect negative cycles also. So if your graph has negative cycles, ऐसे करके अगर negative cycles होते हैं तो Dijkstra does not work. Okay, I'll be answering the questions. ठीक है, first let me explain this कि if there are negative cycles, Dijkstra will not work. ठीक है? In that case you have to use Bellman-Ford if you are not sure कि the graph will have negative cycles or not. ठीक है? So running time of Bellman-Ford is again O of n cube. ठीक है? So this I will not be teaching today. I'll be teaching it in the next session of shortest path, not this week. Probably next week or next to next week. Like recently planned नहीं है. This week is only about graphs. Kal I'll be doing DSU. परसों I'll be doing minimum spanning trees. Next week it'll all be about DP. ठीक है? ठीक है. Your doubt. So ठीक है, डीपी का डर को कैसे भगाना है? डीपी का डर मतलब जस्ट फेस इट. डीपी का जो डर होगा, जस्ट ट्राई टू सॉल्व अ डीपी प्रॉब्लम. लाइक यू नो कि ये डीपी प्रॉब्लम है, उसका सिट विद दैट प्रॉब्लम एंड जस्ट सॉल्व इट. तो उसी से डर होगा, डर जाएगा. एंड यस, वंशी का डाउट, आई हैव अ डाउट. Dijkstra is not short to implement, but you implement it so frequently that you just get used to it. If you find Dijkstra, there's nothing to brief. It's just that today I'll be teaching 3 graph algorithms. One is Dijkstra, which is a single source shortest path. One is Floyd-Warshall, which is a all pair shortest path. So single source means from one node to every other node you are finding the shortest path. The running time of that algorithm is O of n log n, and all pair shortest path means for any pair of nodes you know the shortest path between them. That will take O of n cube time. It's a dynamic programming algorithm, and that's it. The third algorithm, Bellman-Ford, I'll not be doing today. तो Dijkstra से start करते हैं. Any doubts on YouTube? The special class link is in the description itself. So like you can see the description, वहाँ पे लिखा हुआ है join class here. That is the special class का link. ठीक है? If you want to join. Dijkstra actually works in e log n time, but this e can go up to n square, right? It processes every edge, right? So that is why it's e log n time. So mostly it when you are given like a problem that works on Dijkstra, so it's not n log n, it's m log n, but O of n equals O of m mostly for Dijkstra problems. ठीक है? So ये लिखा रहता है ना कि n and m are up to 10 power 5. So they limit m to 10 power 5. But m could have been up to 10 power 10 if they wanted. ठीक है? So when you want to find all pair shortest paths, तब O of n square will not pass anyway. Even O of n square will not pass. So n square log n will also not pass. So ये e log n, e or m log n, whatever notation you prefer. So that this is Dijkstra का complexity. So coming to Dijkstra, how it works. So if you remember BFS, ठीक है? BFS में हम क्या करते थे? Dividing the nodes into levels ऐसे करके, ऐसे बीच में आगे जाता था. But there was never something like this. अगर ऐसा होता तो this node I could have just kept here only, right? ऐसे करके. So this is not in level 2 anymore if this edge existed. ठीक है? So BFS, if you understand, you will know that कि BFS में if all the edges have the weight 1, BFS will give you the shortest path. इसमें किसी को डाउट है? मेरे को ये समझाना पड़ेगा. DFS करते हैं, ठीक है? Let's I'll just work on this cycle. ठीक है? Assume this is a graph and this is your source. ठीक है? If you do a DFS करने से, let's say you start from here, then this will be level 1, level 2, level 3, 4, 5. But these are not the distances, right? DFS. I'm doing a DFS here. If I do a DFS, ठीक है, like it's problem dependent. Sometimes Dijkstra का n square log n वाला solution will work, n square log n वाला solution will work. Sometimes it will not work. Floyd-Warshall is easier. So it depends. Anyway, so yeah, if I do a DFS, I'll first visit this, then this, then this. ऐसे करके 1, 2, 3, 4, 5 होगा, right? But this is not the distance, not the shortest distance. Shortest distance कैसा दिखता? Shortest distance कुछ ऐसा दिखता. 1, this will be 1, this will be 2, this will be 2, and this will be 3. This, if this is your source. But if you look at this, you can see कि this is a BFS, right? Is it a BFS? पहले this will be visited, then this will be visited, and then this will be visited, and then this will be visited, and in the end this will be visited. So this is a BFS order. ये समझ में आ रहा है? Amazing. तो BFS का ordering में, you can see that कि you find the shortest path to every node if the edge weights are 1. ठीक है? Another observation is, what if the edge weights were 2? सबका edge weights is 2. Can you use BFS now? Exactly same thing. Instead of 1, just multiply all the shortest distances by 2. Right? Very easy. So after you learn Dijkstra, you will understand why this works. ठीक है? पहले देखते हैं हमारा Dijkstra का कैसा होता है. So Dijkstra works kind of like BFS. ठीक है? Let's give it some edge weights. Let's work on this cycle only. 1, 2, 3, 7, 1, 1. कुछ ऐसा टाइप का. ठीक है? तो the shortest path to the nodes I'm writing in red, ठीक है? This should be 3, this should be 5, this should be 4, 3, 1. These are your shortest path from your source, ठीक है? So the way Dijkstra works is, first it takes from the first let me explain the algorithm, then we'll debate about its correctness, कि how it's working. ठीक है? YouTube में the people who are watching you, if you want to ask any doubt, you can ask. I'm बीच में checking. ठीक है? ठीक है? So from source, it will first consider all the nodes in a priority queue. ठीक है? A priority queue is basically a heap. ठीक है? Heap का क्या properties होता है? What does a heap do? Is there anyone who doesn't know heaps? It's a min heap. तो min heap क्या कर, तो heaps में क्या, heaps का क्या property होता है? You can insert any element into it in O of log n time. You cannot delete any elements. You can delete the minimum element in O of log n time. ठीक है? These two properties are supported by your min heap. Just insert element and take out the smallest element. ठीक है? तो first assume this is our min heap. ठीक है? तो S से जो भी edges निकल रहे हैं 3 and 1, those I put into my min heap. ठीक है? Then I take out the smallest one. ठीक है? Smallest one I take out and I go there. ठीक है? And I say कि the distance is 1. I'll use red. The distance is 1 till here. And then from that node, I will put everything in the min heap. ठीक है? तो what I'll put? I'll put the distance. ठीक है? Not just the edge weight. So इस यहाँ से edge weight is 2, but the distance will be 1 plus 2, 3. Another 3 I'll put. ठीक है? I haven't visited this node yet. Now my min heap contains 3 and 3. So I can take out anyone, I'll take out the first one. If I take out the first one, I'm visiting this node now. And I'll set its distance to 3. And इससे जो भी edge निकल रहा है, that I'll put into my min heap. So 7 plus 3, the distance, ठीक है? That distance I'm putting into my min heap. Not 7, it'll be 10. 7 plus 3. As of now, समझ में आ रहा है क्या हो रहा है? Then again I'll take out the minimum element, which is 3. I'll visit that node. I'll set the distance. And then I'll add my 3 plus 1, 4 to the min heap. What is the minimum element now? 4. So 4 I'll take out. It's this node. I'll set iska distance as 4. And I will add 4 plus 1, 5 into my min heap. And I have 5. I take it out. I set the distance to 5. And then I take out 10. I see that this node is already visited. I leave it. And my min heap is empty, right? And I'm done. You can see that every node now has its minimum element, right? Heap I will explain. Not the internal working. You will use heap as a black box as of now. Okay? But is this clear ki how this algorithm worked? Like what is the algorithm exactly? What are the steps that we are following? So step 1, take out the node that has the minimum distance in the min heap. Initially source ka distance will be 0. Okay? So take out the node which has the minimum distance. Okay? Then from that node add every edge. Okay? So you take out the node, and from that node whatever edges are outgoing, you into the heap you put that edge edge plus the distance to that node. So basically the distance to the next node. You put the distance to the next node and the node itself in the min heap. Okay? Then you take out the minimum distance wala node. This is not BFS. Okay? So the only similarity with BFS is that BFS does the exact same thing, but instead of a heap, it uses a queue. Okay? So Dijkstra is also kind of visiting all the nodes, right? DFS, BFS, Dijkstra. The work that all of these three are doing are the same. It's just visiting all the nodes in some particular order. DFS के लिए we use a stack, BFS के लिए we use a queue, and Dijkstra के लिए we use a min heap. So it's only the data structure that is being changed. Otherwise, it's the exact same thing, right? Difference between min heap and queue, ठीक है? तो let's talk about min heap थोड़ा सा कि some people some seems like they don't know what min heap means. So queue, if I want to insert an element 1, I'll insert 1, then I'll insert 2, then I'll insert 4, 6, 1. I insert this, I inserted this way. I insert through the back, to the back, okay? So I insert to the back, and if I want to pop out elements, I'll pop it out from the front. So first I'll pop out 1, then 2, then 4, then 6, and then 1. Okay? But min heap kya karta? If I insert 1, 2, 4, 6, 6, 1, first it'll take out this one, then it will not take out 2. It will take out this one. Then it will take out 2, then it will take out 4, then it will take out 6. So it takes the minimum element, not the front element. Queue will always take out the front element. Min heap will take out the minimum element. ठीक है? Irrespective of index. So min heap में the index is not preserved. So the index is the order in which, what's heap? Heap, this is heap. So heap के two types होते हैं, min heap and max heap. In min heap, it will give out the minimum element. In max heap, it will give out the maximum element every time. And like one heap cannot be both. It either has to be min heap or max heap. ठीक है? Yeah, priority queue is min heap. So how do I explain this? You know arrays, right? You know arrays? So arrays is a concept. It's like, think of arrays as concept. So arrays can be implemented using the normal arrays that you know. It can also be implemented using a vector in C++, right? A vector can be treated like an array. Even though the concept is the same, a vector has the properties to be treated like an array. ठीक है? Array का क्या? Constant. Array का एक property है कि the size should be constant. तो vector का size you can keep it constant and still work on it. Retrieving is O of 1. So it's called an abstract data structure, ADT. Abstract data, I don't know T का क्या है, but ठीक है, जो भी है. So basically it's a concept and you उसका एक implementation होगा. Yeah, abstract data type. Yes. And उसका जो implementation है that differs. So min heap is the concept, priority queue is how you implement it. ठीक है? PQ, min heap are the same. PQ is the implementation of min heap. Yeah. So I will implement Dijkstra once. So is it clear ki Dijkstra why it works? Or do you want me to explain ki why this is working? ये समझ में आ रहा है ना? एजेस पॉजिटिव नेगेटिव होने से भी इट विल वर्क अगर नेगेटिव साइकिल्स नहीं है तो. ठीक है? सो आई विल जस्ट इंप्लीमेंट इट वंस so that everything is clear. Screen visible? Yeah. Negative cycle is a cycle in a graph in which if you go through that cycle, the overall sum of weights is negative. Clear? ठीक है, चलो. तो I'll start by taking the graph input. ठीक है, input ले लिया. This is pretty much normal. This part, don't worry about it. This is just a template for me. Like, given a vector, uh, vector int v, and agar you give, you can do v, something like this. So I just explained what negative cycle is. Negative cycle is a cycle in a graph such that the sum of weights in that cycle is negative. So imagine a triangle where all the edges are -1. Now, -1, and 1. So that is a negative cycle. A cycle with negative weights. Anyway, so this part is just doing this. Okay, given a vector, if I do C in V, it will take the vector input. If the vector is given as like space separated integers. So you can ignore that. If you want me to share this template is already there in every code I share. Anyway, graph input मैंने ले लिया. And imagine my source is like the 0th node is my source. ठीक है? And I want to find the weights to every other node. So 0 is my source. So int source equals 0 कर देता. Or rather, let's take the source as input. ठीक है? I took the source as input. Now I'll make a priority queue. This is how you make a priority queue of a single integer. Okay? But this will not work for me. Why? Because I don't want just the weights to be stored, right? I want the this is a thank you. So I will take the weight as input, and instead of int, it will be pair, and this will how I'll be saving them. This is clear कि मैंने कैसे store किया. So every node is now a pair. First is the node number, second is the weight to that node. ठीक है? So node number, weight to that node. Node number, weight to that node. ठीक है? This is clear? तो source मैंने ले लिया. So, yeah, okay. So this will not work because it's containing a single integer. Like weight तो मेरे को देना पड़ेगा. But along with the weight, I also need ki what is the node associated with that weight. So instead of int, I will do pair int. And another thing is that priority queue by default is a max heap. I want it to be a min heap. So what will I do? There are two ways to do this. I can either store minus the weights, not the positive weights. That will work. But better way to do this is to convert it to a min heap. So this is how you do it. So now this is a min heap, PQ. I know this is complicated, but let's try to understand this. The first one is the type. So I know you are confused. So this is how it works. Priority queue. So first will be the type, then it will be ki what do you want the priority queue to use to store the data structures. I wanted to use a vector. So I'll do vector int, and the third one will be a comparator operator. Okay? Like a comparator. Ki given two integers or two things of type. So I wrote int here, it should be type. So of type. Okay? Like let's make it t. Okay? Given two things of that type t, I want to compare them. So how do I compare them? That function, so greater is an inbuilt function which says ki if a you give it two things a and b, it will just say ki a is less than b or not, a is greater than b or not. So it just returns true if a is greater, return false if a is smaller. So if by default the comparator is smaller, but I changed it to greater. So I can do greater of t pq, and now I'm using the opposite comparator, so it's a min heap. तो बेसिकली स्मॉलर होने से इट्स अ मैक्स हीप, ग्रेटर होने से इट्स अ min heap. So this you can like I explained, but you don't really need to know. If you can just remember कि this is a min heap, ठीक है. And Google की कैसे होता है? So priority queue C++, geeks for geeks नहीं, c++.com. So priority queue, you can see कि there are 3 things that you need to give it. The value type, so 3 things you need to give it. The value type, which for me is a pair int. The container type, the container that it needs to use to store the values, okay? That is my vector of pair of int. And the size, I don't think these are the things. Yeah, the compare operator. So type T, container, and compare. These 3 things I need to give. This is a member type, sorry. So is this clear? कोई doubt है? So this PQ is basically my min heap now, which stores a pair of integers, integer and integer. So that pair, the first one will be my distance to that node, and the second one will be the node itself. So initially I'll store pq.push the source, the distance to it is 0, right? And while not pq.empty, I have to perform Dijkstra. So first, what is the first step that I need to do? यहाँ पे the values that I put inside PQ, it's stored in a vector basically now. Like if I make it a set, then it will be stored in a set, but I want it to be a vector. So this is the type, this is the container, and this is the comparator. Anyway, so what is the first step that I need to do? The first step I need to do is extract out the nodes in the top. Okay? Int u will be pq.top.second, and my d will be pq.top.first. So d is my distance, u is my thing, and let's make another vector to store the vector int distance. And let's make it all very 10 power 18. So initially it's all infinity. So 10 power 18 store करके रखा है मैंने. ठीक है. Now, if distance of u is equal to 10 power 18, then I just continue. But I also need to pop before that. So pq dot pop ही होता है I think. ठीक है. So first I took out the node, u is my node and d is my distance. Take a distance to that node. Then I do pop, and if distance to u is not equal to 10 power 18, that means I have visited u before and set the distance to something, right? So I continue. I don't need to worry about it again. And if it has not been visited before, then I set the distance to d. I set the distance, and then for every I in g of u, if I is not visited, if distance to I is equal to 1e18, I need to push it to the queue. Push pq.push of what? What do I need to push? So this won't be int, this will be a pair int. Okay, and distance of what? I dot first or I dot second? कोई बताओ? Second क्यों? This g of u will be this, right? And this distance of that thing, I want this to be the node number, not the weight. So the first is the node number, second is the weight. I want this to be first. So this is the node number. And now pq.push what? What do I push into pq now? कोई बताओ? Any answer? I thought अर्धेंदु को ऑलरेडी आता होगा डाइक्स्ट्रा. तो बताओ क्या क्या पुश करूँ मैं यहाँ पे. Distance of u, what is the distance of u? D, right? So I dot second plus d and I dot first, right? This I store, and then I just print out, and I'm done, right? This is my algorithm. The whole algorithm is this much, and in the end I just print out the distance. So typically you can't print a vector, but since I have these, I can just print a vector and it will print like one by one space separated. It will print. Okay. So problems v was I did v. It should be g. And second distance d is, it will be n. Yeah. So let's work on the graph that we have made before. So what was the graph? Does someone remember how many nodes there were? First I need to give number of nodes and the number of edges. Then I give the 2 nodes and weights. ऐसे करके. So if someone remembers the graph, should I stop sharing my screen and try to remember the graph again? Or I can just draw it. So let's try to draw the graph again. So this is my 1, 2, 3, 4, 5, 6th, I think. And it was a cycle. And the graph goes something like 1, 2, 1, 1, 3, 7. Right? I think this was the graph. So what should be the input? First the number of nodes, which is 6. The number of edges, which is 6. Then I'll give the nodes and their weights. So 1, 2, 1, 2, 3, 2, 3, 4, 1, 4, 5, 1, 5, 7, 1. No, 5, 6, sorry. 5, 6, 7. And 1, 6, 3. Right? And source is my 1. Source ko I forgot to do source minus minus, so I'll just give it like source equals 0. Okay? So 0. So let's see if the output is correct. Okay? So from source to node 2 the distance is 1, to node 3 the distance is 3, to node 4 the distance is 4, to node 5 the distance is 5. So 1, 1, 5, and to node 6 the distance is 3. So this is correct, right? All I need to do here is source minus minus so that I can give it like a 1 based integer. So is the algorithm clear? Is code mein koi bhi doubt hai? Ask me right now. I'll explain. Line 58 to 60, this one. So for every integer, for every pair in G of u, so G of u will be a pair, right? Pair of what? First it will be the node, and the second will be the node from u to that node. So this just means distance from u to I dot first is I dot second. This is what it means. So if distance of I dot first is 10 power 18, if it's not 10 power 18, that means that I dot first has been visited before. If it's equal to 10 power 18, that means that I dot first has not been visited now, till now. So first I need to store the distance to I dot first, which is I dot second plus the distance to u, to I dot second plus d. And the second one should be the node, which is I dot first itself. So this is what I'm pushing. D, which is distance from source to u, plus u to I dot first, which is I dot second. And finally I'm pushing the node itself, which is I dot first. So this is what I'm doing. So I'm just, D is the distance from source to u. I dot second is the distance from u to I dot first. So what is the distance from source to I dot first? It's d plus I dot second, right? So that is what I'm pushing into my priority queue. And the second will be the node itself, which is I dot first. So clear? Anyone line numbers पूछो, I'll explain कि क्या हो रहा है. This is my input, nm लिया, मेरा ग्राफ लिया, and then source लिया. Distance array को initialize किया, priority queue बनाया, which is my min heap. Max heap होता it would have been easy for me to initialize. Then मैंने source को push किया, distance of 0 के साथ. Then while my priority queue is not empty, I am just performing Dijkstra. And then I'm just printing the distance array. And this was the output. ठीक है? Questions? No questions? Okay, so now we can do distance of neighbor will be equal to distance of node plus not 1, it will be distance of the node plus the weight from node to that neighbor. You just copy paste it. That template, I didn't write it. I copy pasted from someone that I found, and I found this template interesting. It helps me a lot. So I just copy pasted it. I didn't write it myself. I understand it, but I didn't think of it myself. Okay, so Dijkstra is clear, right? So next up, we can either solve a problem on Dijkstra or we can move to Floyd-Warshall. So what do you want to do? Solve a problem on Dijkstra or move to... Okay, I got your... More people I want to answer. I am not sure कि कौन कौन है class में. Problem on Dijkstra, ठीक है. So most people want problem on Dijkstra. I'll just share the screen and move to the problem itself. एक minute. Let me just resize the window so that chat दिखे while I'm showing the problem. So this is an interesting... हाँ तो पता है मेरे को कि 3 बजे नींद आ जाता है. That is the exact reason I'm trying to reschedule for the next class. ठीक है, anyway, let's look at this problem. ठीक है, it's a Codeforces educational round E. ठीक है, not like a very very interesting problem on Dijkstra. ठीक है, so what it does is it's saying that you have a graph with n vertices, m edges, standard stuff, and for a path, okay, let's see if this is dp plus Dijkstra. पहले पढ़ते तो हैं. For a path, the weight of that path will be all the weights in that graph minus maximum of the weights plus minimum of the weights. ठीक है, ठीक है. If you already solved it तब तो बढ़िया है. But I'll still be giving working on this problem only. So this is the cost of a path. So all you need to do is one say, I think, yeah, first vertex से ith vertex तक you have to find every distance, and this is how the cost is defined as. Your n and m are given, weight can be up to 10 power 9. I don't think anything else is important here. It's like a really short problem statement. तो सोल्यूशन बताओ कैसे डीपी प्लस डाइक्स्ट्रा कैसे. आई मीन टैग्स में तो मेरे को नहीं दिख रहा डीपी. बताओ कैसे कैसे सॉल्व किया इसको. ओके, प्रॉब्लम एक्सप्लेन. Okay, I'll just explain the first example. ठीक है, The first example says, okay, the first example is 5 nodes, 4 edges. So 3 to 5, the weight is 4. 1 to 2, the weight is 1. 1 to 2, the weight is 1. 3 to 2, the weight is 2. And 2 to 4, 5 to, oh, 3 मैंने 2 बार कर दिया. Yeah, this is 3. And 2 to 4, the weight is 2. The weight is 2. ठीक है. So from 1 to, from 1 to 2, what is the distance? 1. But I have to also do minus of max plus of min. So 1 to 2 minus 1 plus 1 करूँगा. तो 1 to 2, the distance is 1. From 1 to 3, ठीक है. 1 to 3, the distance will be 4. But I have to do minus max minus 3 and plus min plus 1. Make sense? So this will be 2. तो 1 to 3 का जो distance will be 2. 1 से 4 तक का distance. 1 से 4 तक का distance is 3, but minus maximum 2 plus minimum 1. So it will be 3 minus 2 plus 1, which is 2 again. So and 1 से 5 तक का it will be 4, 3, 8, the sum, minus max, which is 4, plus min, which will be 1. So 8 minus 4 will be 4, plus 1 will be 5. Did I do some calculation mistake? Anyway, in that path, I want to do minus max plus min. So anyway, let me see if I did any calculation mistake here. So 1, 2, 1, 2, 3, 2, and 3, 5, 4. So 7 plus 1, 8, minus the max, which is 4, and plus min. Yeah, so 4 plus 1. Yeah, why is it 4? This should be 5, no? Minus max plus min. Yeah, this is the board. So 1 say 5. I drew the graph correctly, I think. Yeah, it is a tree. I drew the graph correctly. So 3, 2, 2. It's 1, 2, 2, and then the output is 4, but it's coming 5 for me. Oh, this is 1, 2. Yeah, सही है. तो ये कैसे में सही हो गया? 1 से 3 तक का the distance will be 3 minus 2 plus 1. Yeah, I did this correctly, but I don't know how. चलो कोई नहीं. So it will be 7 minus 4 plus 1 now. Yeah, now it's 4. सही है. So yeah, so the question makes sense now, right? Like it's obvious you need to use Dijkstra here, but how? Like to each, like from source, you are in some node you want to know ki you have deleted the maximum, the minimum, you have deleted the maximum edge and added an extra minimum edge. Like how do you do that? And the DP solution, Ardhendu, you can tell me ki what the DP solution is. मेरे को I won't call this DP. Yeah, I won't call that DP. It's just normal Dijkstra. How is that DP? लाइक डीपी के लिए एक रेकरेंस होना चाहिए एंड ओवरलैपिंग प्रॉब्लम्स को सॉल्व करने के लिए उसको सेव करना पड़ेगा, वैसा टाइप का कॉन्सेप्ट होना चाहिए, बट यहाँ पे तो नहीं है वो। यहाँ पे जस्ट जस्ट नॉर्मल डाइक्स्ट्रा। यस, थैंक यू जावेद। I'm stopping the screen share. Tell me how you'll solve the problem. बताओ कैसे कैसे करोगे? बहुत बड़ा तो नहीं है, इट्स वेरी स्मॉल। लाइक एक्सप्लेन करना हो तो, लाइक इम्प्लीमेंट करना हो तो ओके। नॉट एक्स्ट्रा कीप ट्रैक ऑफ द वेट दैट इज एडेड टू द पाथ यूजिंग टू वेरिएबल्स, ठीक है? ओके, मेक सेंस। So Muskan says कि we can now run just a normal Dijkstra and keep track of the weight that is being added to the path using two variables. I suppose ki the two variables, one is keeping track of the maximum weight that is added and the other is taking minimum weight. Yeah, but that won't work hamesha, right? Ki like first you find like that won't work. Let me give you a counter example. ठीक है, तो sum wise let's say कि let's say this is your graph, ठीक है? तो initially if you run a Dijkstra you will see, you'll find this as the minimum and then you will see कि यहाँ से maximum को हटा दो, minimum को add कर दो। तो overall you are seeing कि the distance to here is 6, but the distance to here is actually 4. Why? Because if you take this part, this path, if you take the blue wala path, if you take the blue wala path, then it's 1 1 1 10. If you remove the minimum and add the maximum, it will be 4, right? So it's 13 minus 10 plus 1. So this is a counter example to your solution, Muskan. But yeah, that is a good try. That is a good first try. So just initially running the Dijkstra and then finding the minimum and maximum will not work. You have to somehow incorporate the minimum maximum while running the Dijkstra. Okay, we need to do the Dijkstra. Yeah, you need to keep the Dijkstra while keeping the minimum and maximum. Yeah, the net result should be minimum. So how will you do that? Some observations on the problem you need to do. DP नहीं है यार ये. नहीं, this is not DP. I'll explain the exact same solution and I will not call it DP. It's not DP. DP से कैसे, like DP नहीं use हो रहा है. You are just calling that DP. लाइक वो अरे का नाम जो है वो मैं डिस्टेंस रख दूंगा तो इट्स नॉट डीपी, इफ आई कॉल इट डीपी इट विल बी डीपी, ऐसे थोड़ी होता है। मैं इनपुट लेते टाइम मैं जो अरे बनाता हूँ उसको मैं डीपी नाम दे दूंगा, तो इज माई सोल्यूशन डीपी नाउ? नो राइट। The path away maxway will go along that path for a... Okay, for one very important observation you need to make कि if let's say you somehow try to find कि from any node to any node you want to find कि you want to delete any edge and then find the minimum, ठीक है? Like delete any edge and add any edge and find the minimum, ठीक है? तब by default the maximum edge will be deleted and the minimum edge will be added. Is that a valid observation? Like suppose मैं बोल रहा हूँ कि right now I'm just deleting the maximum wala edge and adding the minimum wala edge again, right? But instead of that, if I removed that minimum maximum wala condition, I said कि you can add any edge and delete any edge and then find the shortest path, but that shortest path will always delete the maximum edge and minimum edge anyway, right? This path has 13, ठीक है? I'm saying कि you can add any edge and delete any edge. So if I do -1, like if I didn't do -10, instead of that I did -1, so the weight will always be more, right? So if I just remove that condition कि मेरे को maximum वाला ही delete करना है and minimum वाला ही add करना है, even then if I find the minimum if I find the shortest path, that shortest path by itself should always delete the maximum edge and add the minimum edge. Does that make sense? I just removed it. So initially it was sum minus max plus min, right? But this max min, I am removing that condition. I am saying कि sum minus any edge plus any edge. ठीक है? Now find the shortest path. So the shortest path should do minus max plus min anyway, right? So I'm just removing the condition कि maximum minimum ही remove करना है. Now my problem reduces to this कि I can remove any edge, add any edge, and I still any weight, actually not edge, like change this edge to weight, ठीक है? So I can remove any edge, add any edge, now find the shortest path, ठीक है? So that will give me my answer. These both will give me the same answers हमेशा, right? We use Dijkstra shortest path algorithm, relaxing the counted distance. What do you mean by relaxing the counted distance? Like चलो YouTube में someone is answering, so I'm checking your answer. बताओ, what do you mean by relaxing the counted distance? Yeah, so if I tell it कि you can add any edge and remove any edge, it will anyway just remove the maximum and add the आपका solution, what was the... add then 2 into 8. If subtract then don't add w. If both... हाँ भाई, that is the solution, but that is not DP. Your solution is correct, but it is not DP. That is what I'm telling you. You are just calling your array DP. That does not make it a DP. So a DP solution. I'll just explain the solution कि कैसे हो रहा है. So each, so मैं एक नया ग्राफ बनाऊंगा, ठीक है? And that in that new graph I will make the edges in a very specific way, ठीक है? So in that new graph I'll each node, yeah, I'll explain with the example. So let's say this is, ठीक है, your 2 3, ठीक है? This is your graph. So I have to take a very simple graph for it to for the example to make sense. In the new graph, I'll take every node. I'll take each node will be a triplet of numbers. Okay? I, x and y. So x and y are both either 0 or 1. So x and y are bits. So x is telling me if I have added an edge till now, and y is telling me if I have removed an edge till now. Okay? This will make more sense once I start making the example. So what are the nodes that I'm making? So 1 0 0 will be there, 1 0 1 will be there, 1 1 0 will be there, 1 1 1 will be there, then 2 0 0, 2 0 1, 2 1 0, and 2 1 1, and finally 3 0 0, 3 0 1, 3 1 0, and 3 1 1. So how many? So if my original graph has n edge n nodes, how many nodes will the new graph have? बताओ. Exactly. 4 into n number of nodes होना चाहिए, right? So in this new graph, I'm just saying कि suppose 1 0 0 से 2 0 0 I'm going. ठीक है? So that means I have not added any edge or removed any edge. So the weight should be 2, and 1 0 0 से I'm coming to here. So that this one means that I have removed an edge अभी तक. If I have removed an edge, that means this edge is removed, right? So इसका weight should be 0. ये समझ में आ रहा है? And if I go from 1 0 0 to 2 1 0, तो फिर I have added an edge till now, तो फिर the distance should be what? 4. And यहाँ से यहाँ I'm going. So that means कि I have added and subtracted an edge. That means again 2. ठीक है? Now from 2 0 0 to 3 0 0. So 2 0 0 तक I have not added or subtracted any edge. From 3 also I have not added or subtracted any edge. So it should be 3. From 2 0 0 to 3 0 1. It will be not 5, 3. This is the edge. Shortest, no, not the shortest path. ठीक है? Now what is this edge? 2 0 0 to 3 0 1. 0. Exactly. अब समझ में आ रहा है what I'm trying to say? From 2 0 0 to 3 1 0. So till 2 I have not added or subtracted any edge, but from 2 to 3 I have added one edge. So this will be 6. बढ़िया. And this will be 3 again. And similarly इसका भी कुछ होगा ऐसे कैलकुलेशन, एंड इसका भी होगा, इसका भी कुछ होगा कैलकुलेशन. ठीक है? ये कैलकुलेशन क्या होना चाहिए? So till 2 I have only added one edge, but then from 2 to 3 I have also subtracted an edge. So this must be 0, right? 2 1 0 say 3 1 1. That means I have subtracted one edge. टू 1 0 से 3 1 1 जाने का मतलब क्या है? 2 1 0 2 1 0 say if I'm going to 3 1 1. How is that possible? If I remove one edge, right? If I remove one edge, if I remove the edge from 2 to 3, वो वाला edge अगर मैं remove कर दूं, तभी जाकर I can come to 3 1 1. Otherwise I can't, right? So this edge weight must be 0. ठीक है? अब 3 1 1 आने का और क्या क्या ways है? 2 1 1 से I can come to 3 1 1 and keep it 3, right? अब 3 1 1 से if I want to come from 2 1 0 to 3 1 1, तब क्या होगा? तब 6 होगा, राइट? लेट मी यूज अ डिफरेंट कलर. सो 210 से आई एम कमिंग टू 311, तब 6 होना चाहिए द वेट. 201 से 311, तो आई एम एडिंग वन एज, तो 6 होना चाहिए. ठीक है. नाउ इफ यू, हाँ 3+3, तो इनिशियल 3 था, आई एम एडिंग अ 3 ऑन टॉप ऑफ इट, तो इसलिए इट बिकम्स 311. मेक सेंस, राइट? बढ़िया. सो इफ यू फाइंड द शॉर्टेस्ट पाथ फ्रॉम 100 टू 311, क्या होगा वो? What are the possibilities? This is 5. This is, yeah, 5. This is 6. This is 4. And this is 5 again. So what is the minimum distance? 4, right? And that 4 is coming from 100 to 210. And from 210, it's coming to 311. So you can see कि by default it removed, it added the minimum edge and removed the highest edge. So it added 2 and removed 3. So that is why I got 4. So 4 is what? My 5 minus 2 plus 3, right? Sorry, minus 3 plus 2. Five minus 3 plus 2. If you are given minus min plus max, yeah. If you want to find minus min plus max, then it will not work. It's the crucial piece of information that we are using here is the fact that if you are allowed to remove any edge and add any edge by and find the shortest distance anyway, you'll get the sum minus max plus min. तो समझ में आया क्या हो रहा है? So I make this new graph, and in this new graph I run a Dijkstra, and then 211 तक का distance, 311 तक का distance, 411 तक का distance, all these distances are my answers now, right? Up to n11. So this is my answer. I just print it and I'm done. So last step, no, there is no last step. Yeah, just the 211. Why 211? Because till 2 I need to have removed one edge and added one edge, right? That is my answer. So in the last step I'll just print 211, 311, 411 up to n11 का जो भी distances निकला मेरा in this new graph, that is my answer. So what is the complexity? The complexity will be O of 4n log n, right? This is my complexity. इसका implementation I haven't done yet. What is this that I have implemented? I've implemented some other thing. I don't remember what I implemented. So this problem I found really interesting, but I have not implemented it. इसका implement अभी I don't have time left. तो मेरे को implement करके debug भी करना पड़ेगा, right? इसका implementation is also available. Help नहीं, class के बीच में I don't want to waste my time just trying to implement. I'll just quickly do Floyd-Warshall. I have 20 minutes left. I'll try to do Floyd-Warshall. One implementation I have done. Okay, do you want to do one more problem which I have implemented, or do you want to जो problem implement मैंने किया है, मैं भूल गया कि मैंने क्या implement किया. Let me see. Yeah, जो मैंने रहने देता. I actually forgot what problem I implemented. I lost the problem. So I'll just do the topic for now. तो प्रॉब्लम इधर मेरे को अभी ढूंढना पड़ेगा या फिर समथिंग लाइक दैट. सो प्रॉब्लम आई प्रिपेयर्ड वन बिकॉज 2 टॉपिक्स कवर करने थे एंड एक प्रॉब्लम कवर करना था. एंड इन वन वीडियो, इन वन लाइव सेशन आई कैन ओनली कवर थ्री थिंग्स. यूट्यूब में देर आर नो ओपिनियंस, बट यहाँ पे बहुत बहुत ही ज़्यादा हीटेड डिबेट. तो फ्लॉयड वॉर्शल कर लेता because I haven't prepared another problem. I have prepared for Floyd-Warshall rather. Wait, problem. Okay, I remembered the problem, but I don't have the link to it. Batao? It's easier than this one. Chalo. And Rahul, do you want to do the problem or do you want to learn Floyd-Warshall? कौन सा implementation? It's either another problem or Floyd-Warshall. One among them. Okay, Floyd-Warshall, right? ठीक है. तो Floyd-Warshall ही कर रहे हैं हम. Yeah, Floyd-Warshall, as I said, it's a all pair shortest path algorithm, and the running time complexity is O of n cube. It's really easy to implement, 3 lines of code. The main idea behind it is like ki, suppose your dp I j is your shortest path from I to j. This is what you want. Okay. So what you do is this will be so for every k you just set it as dp ij equals, like for a particular k it will be set as dp ij comma dp of I, सिर्फ कॉमा लिखता हूँ, k plus dp of kj. This is it. So for you take a k, so what k is a middle node, right? So I to j ka I want to find the minimum distance. What I do is decompose that. So I take a k, and for every such ij I decompose that ij to go from first I to k and then k to j, and I see if this is a minimum or not. If this is less than directly what I have found till now for I to j, then my new shortest distance from I to j will be through k. समझ में आ रहा है? So literally इसका implementation is just 3 lines of code. And yeah, इसका implementation is better done with a I'll give the example once. Let me just implement Floyd-Warshall. This I'll keep for now. ठीक है. So तुम्हारा n and m आ गया, and let's make it a matrix. ठीक है. Floyd-Warshall works on a matrix. So let's your g will be my now and my distance. So I made 2 vectors, one g and one d. Initially it's a so both of them are n into n matrices. Okay. So for I equals 0, I less than n, I plus plus, I'll just do c in vi, and then gi, sorry, and then my distance initially will be equals to g. Okay. So this I need not do, initialize करने की ज़रूरत ही नहीं है. So distance is equal to g. So now I'll just work on my distance. So for I'll take a k, int k equals 0, k less than n, k plus plus. Okay. And all the distances that are 0, I will make them. So for int I equals 0, I less than n, I plus plus. For int j equals 0, j less than n, j plus plus. If I is not equals j and the distance is 0, so distance of I to j is equal to 0, so I will make it infinity. So 118. Okay. So initially all the distances I'm setting it to 118 if there is no edge between them. Okay. So for every k, what I'll do is I'll take two nodes, right? So first I need to check if all of them are different. So if I is not equals j and j is not equals I and sorry, j is not equals k and I is not equals k. So 118 की जगह 115 कर देता, so that it doesn't overflow. So distance of ij will be equals min of distance of ij, distance of ik plus distance of kj. This is it. So this is my Floyd-Warshall, and in the end, distance of xy is equals min distance from x to y. This is it. तो implementation समझने में कोई problem हो रहा है? As an example, let's use a smaller graph. So something like 1, 2, 3, and let's make this 1, 2, 4, something like this. Okay, so okay, this is a complete graph. All of it is already filled. So let's take a 4. एक node 4 है which is 1. ठीक है? So इसका distance is 1. Let's make, yeah, the graph looks fine. Complete graph is allowed, but if it's a complete graph, then distance is already filled, right? This loop will not do anything. It actually will. So let's work on the complete graph. So complete graph will be an interesting case. Okay. So complete graph hai. So initially my matrix will look something like this. It's 1, 2, 3, 1, 2, 3. It will be 0, 0, 0. This is my distance matrix. Okay. So 1, 2, 2, it will be 1, 1, 1, 2, 3, it will be 2, 2, and finally this will be 4, 4. So this is my initial distance matrix. Okay. So k, so initially k goes from 1 to 0. So first k will go from first k will be 1. So if k is 1, this okay, I wrote for, this should be if, sorry, if, yes. Okay. So these three conditions will only be satisfied if I is 3, if I is 2 and j is 3, and otherwise also, so it doesn't matter, it will be the same thing. So assume I is 2, j is 3. Okay. In this case, I'll see that distance of distance of 2, 3 will be equal to minimum of these two values, initial values of distance of 2, 3. So distance of 2, 3 is what? 4, right? So initial value is, okay, let me just write minimum of distance of 2, 3, distance of 2, 1 plus distance of 1, 3. Okay. So this is equal to minimum of distance of 2, 3, which is 4, or 1 plus 2 equals 3. So now my new distance 2, 3 will be 3. So this changes to 3. And this 4, this second 4 will change to 3 as well. This will also change to 3. Why? Because for the case I equals 3 and j equals 2. Make sense? And after that, the graph will not change at all. So you can see that even for this complete graph, where it was initially all filled, it found the minimum distance. We are setting that because if it's not a complete graph, okay, assume the graph looks something like this. So I'll use the exact same thing. 1, 2, sorry, 2, 3, and finally a 4. Okay. So this is 4, this is 1, this is 2, and assume this is 1. Okay. So in this case, 1, 2, 3, 4, 1, 2, 3, 4. So this should be 0, 0, 0, 0, and 1 to 2 is 1, 1, 1 to 3 is 2, 2, and 1 to and then 2 to 2, 2, 3 will be 4, 4, and 4 to 2 will be, this will be 1, this will be 1, and the rest of the empty values, 26th line. 26th line. 26th line is it's fast IO. I'll explain. So initially the empty values that are there, I'm just setting it to infinity. So my infinity ka value is 10 power 15. That is what I meant. So this is my initial array in this case, initial matrix. So in this case my matrix was this. In this case my matrix is this. Make sense now? Because from 4 to 1 I still don't know the minimum distance. So I have to set it to infinity. So that is why I set it to 1u15. 1u15 means 10 to power 15, right? Okay, this line is just fast IO. Okay? That is what it means, nothing else. Like it increases the like some syncing it doesn't do anymore, so that the input output becomes faster. And in competitive programming, that is what you want, right? You don't want your input output to be the bottleneck of your code. Anyway, so Floyd-Warshall समझ में आया? Where you take distances, ये यहीं पे C and GI. So GI is a vector, right? That vector I can just take because of this thing. And then distance को G बना दिया. And then distance का जो भी 0, 0 होगा उसको मैंने 1u15 बना दिया, मतलब infinity बना दिया. So ये कि if I not equals j and still it's 0, then it becomes infinity. So I not equals j and distance is 0, then I make this infinity. And उसके बाद I just run Floyd-Warshall and I'm done. तो Floyd-Warshall literally 5 लाइन का कोड है. 3 for loops, एक if statement and एक actual statement. So both of these codes I'll be sharing right now अभी. And the problem link उस problem का जो which I discussed अभी, I'll share it right now. ठीक है? पूरे सेशन में कोई डाउट? I think you guys are the same people, Pratham Verma, but it's okay. Yeah, the implementation of that problem, I will just send the implementation that they wrote. It's the same thing. मतलब मैं क्या ही extra करूँगा. ठीक है चलो, then I am leaving. As usual, thank you both of you for sticking till the end and making the class इतना interactive. ऐसे ही बात करते रहो, मेरे को मज़ा आता है तुम लोगों को पढ़ाने में. हाँ, you also Vamshi. So Vamshi, Ardhendu and Rahul, और कौन? तुम तीनों ही. चलो बढ़िया. So tomorrow I'll be doing DSU and DSU का problems. उसके बाद I'll be doing minimum spanning tree. तो कल के सेशन में आना in case you want to do a new data structure. तो कल मिलते हैं. I'll try to change the ये all my timing अब. So एक बार बता देना कि कौन सा timing is good for you. Not in AM please. Something after, like after this शाम को. I mean हो तो रहा ही है. 3 चीजें I can do, I realized. लाइक अमंग टॉपिक्स या प्रॉब्लम्स. तो एक टॉपिक आई कैन कवर. सो कल हाँ वही 30 minutes ईच टाइप का वही होता है. सो मैं तीन ही चीज़ कवर करता हूँ. आज वो कवर करने का प्लान ही नहीं था मेरा. आई जस्ट इम्प्लीमेंटेड, लाइक मैंने खुद सोचा एक प्रॉब्लम. आई इम्प्लीमेंटेड दैट. आई डोंट नो वेयर टू सबमिट बिकॉज वो प्रॉब्लम एग्जिस्ट नहीं करता. एंड बस. तो इसीलिए आई डेंट शेयर इट. ठीक है. एनी मोर कंप्लेंट्स, फीडबैक, कुछ भी है बताओ. फिर आई एंड द क्लास. यूट्यूब ऑल्सो. हेलो वत्सल, बीन अ लॉन्ग टाइम. 7 to 8, 8 to 9. I don't know. You guys tell me. हार्ड प्रॉब्लम. तो वही थिंग इज दैट कि हार्ड प्रॉब्लम इफ आई ट्राई टू इम्प्लीमेंट इन क्लास कि लाइक आई हैव नेवर इम्प्लीमेंटेड बिफोर एंड वो मैं अभी इम्प्लीमेंट करूंगा. तो फिर डिबग करने में काफ़ी टाइम चला जाता है. क्लास इज ओनली 1.5 hours लॉन्ग. सो मैं अभी बैठ के डिबग करूंगा तो 2 to 3 hours भी लग सकता है. सो व्हाट्स द पॉइंट. ठीक है. 7 to 8. I'll take these into consideration. I also Ardhendu, I saw कि Discord में you told कि कुछ AM में you gave time 11 AM to something 12 I think. Yeah, वो तो नहीं possible है because मैं सो के नहीं उठता हूँ तब. I think yeah, I'll make a poll on Google Docs or something. I don't want to work with bots. I mean क्यों ट्रोल कर रहे हो यार अरित्रो. नहीं, मेरा ब्रेन मॉर्निंग में फ्रेश नहीं रहता. चलो ठीक है. चलो I'll end the class now. Thank you for sticking till the end again as usual. एंड कल मिलते हैं फिर. सेम टाइमिंग. अरे बाप रे.